Hi everyone, welcome back to my channel. You are watching Education to All. So today topic is Introduction to Trigonometry, exercise 8.3. So question number 4 given. Prove that the following identities where the angles involved are acute angles for which the expressions are defined. Cosecant theta minus cot theta whole square, which is equal to, we need to prove it as 1 minus cos theta by 1 plus cos theta. So for that I am taking LHS. So we clearly observe LHS is in the form of cosecant theta minus cot theta whole square. So cosecant theta we write it as 1 by sin theta, 1 by sin theta, minus cot theta we write it as cos theta is divided by sin theta. So together have whole square. So take LCM as sin theta. So denominator cos sin theta is LCM. So numerator 1 minus cos theta. Separate the whole square. So 1 minus cos theta whole square and sin square theta. Sin square theta we can write it as 1 minus cos square theta by using an identity 1 minus cos square theta I am writing. In numerator 1 minus cos theta, I will write it as again 1 minus cos theta. So denominator is writing as 1 square minus cos square, which is writing as an identity again a square minus b square is equal to, we can write as a plus b is multiplied to a minus b. Okay, so such a way I'll use this identity 1 plus cos theta is multiplied to 1 minus cos theta. In a numerator we write it as 1 minus cos theta is again multiplied to 1 minus cos theta. Here 1 minus cos theta, 1 minus cos theta cancel. Still what was pending? Numerator 1 minus cos theta is denominator 1 plus cos theta. So this is our requirement. So therefore RHS is the, we got it. So therefore we got RHS. So first one is proved. Similarly second question. What was the second question? It was given cos A divided by 1 plus sin A plus 1 plus sin A by cos A, and we need to prove it as 2 times of secant A. So let us take LHS alone. So LHS is equal to cos A denominator 1 plus sin A plus 1 plus sin A denominator cos A. So take LCM. So by taking LCM in a denominator, so LCM is taken as 1 plus sin A is multiplied to cos A. Then 1 plus sin A, 1 plus sin A cancel, cos A into cos A, which gives us cos square A plus cos A cancel, 1 plus sin A multiply to itself. So it will get it as 1 plus sin A whole square. Got it? 1 plus sin A whole square that expand as A plus B whole square, such as A square plus B square means sin square A plus 2AB. 2 into 1 into sin A. So in denominator we write it as 1 plus sin A is multiplied to cos A. Got it? So next one. And here we have cos square A and it is sin square A. These both adding together, it's an identity. It will form 1 plus 1 square is 1 plus 2 into 1 is 2 into sin theta. In denominator 1 plus sin A multiplied to cos A. Okay. Then 1 plus 1 is 2. So write it as again 2 plus 2 sin A denominator 1 plus sin A is also multiplied to cos A. So numerator identify both having 2 as common. So write it as 2 taken as outside. Still what is pending 1. In second term only sin A. Got it? In denominator 1 plus sin A multiplied to cos A. Okay. Any cancellation is 1 plus sin A, 1 plus sin A cancel. Still we got it as 2 divided by cos A. So cos A in a denominator I can write it as in numerator as secant A. That's all right. So 2 secant A. This is what RHS. Got it? So therefore this is also proved. The RHS we got 2 into secant A. So let us do the third question. Tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta, which is equal to 1 plus secant theta into cosecant theta. So actually in the textbook given hint, write the expression in terms of sin theta and cos theta. So remember, but in exams these type of hints are not given. 3. So tan I am writing as sin theta is divided by cos theta. In a denominator cot. So cot we write it as cos theta is divided by sin theta, plus cot again write it as cos theta is divided by sin theta. In denominator 1 minus tan. Tan I am writing as sin theta is divided by cos theta. So now take LCMs in a denominator. So this will be sin theta is divided by cos theta. In denominator taken as LCM sin theta. Got it? So here it is 1. So 1 is multiplied to sin theta. So sin theta minus cos theta. In the second term, so plus in denominator cos theta will be the LCM. So then here it is 1. So multiply cos theta upside, cos theta minus sin theta. In numerator we have cos theta divided by sin theta. Okay. So this further written in the form of, in numerator I am writing sin theta divided by cos theta, and this will be reciprocal. So writing in a sin theta in numerator, denominator is sin theta minus cos theta. Okay. So here also we can write it as cos theta is divided by sin theta multiplied to cos theta. In denominator, actually in the first term we got sin theta minus cos theta, but second term we having cos theta minus sin theta. So I'll take it as negative outside. So sin will be positive, cos will be negative. That negative I'll multiply here, plus into minus minus. Okay. So now take the LCM for the denominator. So what was the denominator having? Cos theta sin theta. So write it as sin theta is multiplied to cos theta, and sin theta minus cos theta, sin theta minus cos theta. So one time writing na enough, sin theta minus cos theta. So now here cos theta, sin theta minus cos theta, sin theta minus cos theta cancel. So which is having sin theta pending. So already sin theta into sin theta. So sin theta into sin theta, sin square theta, again multiply sin theta. So we'll get it as sin cube theta in the same pattern. Here sin theta cancel, and sin theta minus cos theta cancel. Still what we have? Cos theta alone pending. Already cos into cos, cos square into cos. So we'll get it as cos cube theta. By using the numerator, we have a rule a cube minus b cube. It is look like a cube minus b cube. There is a formula. We can convert a minus b is multiplied to a square plus b square plus ab. So expand this format. So where a is equal to sin theta, b is equal to cos theta. By simplification, so just I am getting as sin theta minus cos theta is multiplied to a square. A square in the sense sin square theta plus b square is cos square theta plus ab. Ab means sin theta is multiplied to cos theta. In denominator, so I will take it as sin theta is multiplied to cos theta and sin theta minus cos theta. Any cancellation we identify as definitely. So sin theta minus cos theta, numerator and denominator eliminated. And sin square theta plus cos square theta is an identity, that gives 1 plus again we have sin theta is multiplied to cos theta. In denominator sin theta into cos theta. Now divide it into separately. So split the division, 1 by sin theta into 1 by cos theta plus sin theta is multiplied to cos theta divided by sin theta into cos theta. Okay, then sin theta cancel, cos theta cancel. 1 by sin theta means I can write as cosecant theta into 1 by cos theta we can write as secant theta, plus this both cancel 1. So therefore requirement is 1 plus secant theta into cosecant theta. This is what RH is. I hope you understood well. So let us move for the next question. Question number 4. So question number 4 is given 1 plus secant a is divided by secant a, which is equal to sin square a by 1 minus cos square a. Hint is given, simplify LHS RHS separately. Again I am saying, so hints and all not expected in the examinations. So try to do this type of questions, LHS separately, RHS separately. Let us consider LHS is equal to 1 plus secant a divided by secant a. Secant a we can convert as 1 by cos a. So 1 plus 1 by cos A, in denominator 1 by cos A. Numerator take LCM. So by taking an LCM, cos A will be the LCM. So cos A, here it is 1. So multiply cos A upside, cos A plus 1, in denominator 1 by cos A. Okay, so this denominator and this denominator cancel, so we get it as cos A plus 1. So it's make an equation number 1. Now similarly take RHS separately. So therefore RHS is equal to, I'll take RHS as given as sin square A is divided by 1 minus cos A. Okay, then sin square A in an identity I write it as 1 minus cos square A, denominator 1 minus cos A. So cos square A was there, so I'm writing 1 square as 1 square. I'll write as 1 as 1 square minus cos square A, which is can be written as A plus B into A minus B. So therefore 1 plus cos A multiplied to 1 minus cos A, in denominator 1 minus cos A. Okay, so any cancellation? Yes. So 1 minus cos A, 1 minus cos A cancel, so we get it as 1 plus cos A. So let us imagine equation number 2. Identify equation 1 and 2. So 1 plus cos A, again 1 plus cos A. Therefore LHS is equal to RHS. Hence it was proved. Done. Next question. Question number 5. So given cos A minus sin A plus 1 denominator, cos A plus sin A minus 1, which is equal to cosecant A plus cot A. So use an identity, cosecant square A is equal to 1 plus cot A. Okay, so we have to use an identity. So before using the identity, I just divide each and every term with the sin A. So let us divide the sin A each and every term. So we'll get it as cos A is divided by sin A, cos A divided by sin A minus sin A is divided by sin A plus 1 divided by sin A, in denominator also same, cos A is divided by sin A plus sin A is divided by sin A minus 1 by sin A, each and every term divided by sin A. So in numerator divided, denominator divided, it will balanced, so no problem. So then by dividing cos A by the sin A, by dividing cos A by sin A, I get it as cot A minus sin A cancel, we get it as 1 plus 1 by sin A we can write as cosecant A, in denominator cos A by sin A, which is equal to cot A plus sin A cancel, 1 minus 1 by sin A will be cosecant A. Okay, so then here this 1 in numerator I will write it as identity based on cosecant and cot. So we have a rule, cosecant square A minus cot square A is equal to 1. Use this identity as a place of 1 by writing the value cot A plus cosecant A, that 1 I am replacing as cosecant square A minus cot square A. So minus of cosecant square A minus cot square A in a denominator. So not to replace anything, just write as usually. So that will becomes cot A plus 1 minus cosecant A. Okay, so this is cosecant square A minus cot square A. So just replace as A plus B into A minus B format. So this can be written as cot A plus cosecant A minus. So it is writing as A plus B means cosecant A plus cot A is multiplied to cosecant A minus cot A. Okay. Now in denominator as usually write, what was there, cot A plus 1 minus cosecant A. Okay, so in the here we have cot A plus cosecant A, cot A plus cosecant A, that alone I am taking out. So cot A plus cosecant A is taken out. So what is pending in here? So there is only one pending, minus of. So this is taken out, it was pending. So what is the minus is there naturally. So if I take this is outside, so it was pending. So therefore minus of cosecant A minus cot A. So actually minus was there, minus into minus will become plus cot A. So in denominator, cot A plus 1 minus cosecant A. Observe numerator and denominator carefully. Here plus 1, so plus 1, minus cosecant A minus cosecant A, plus cot A plus cot A, which means these both are same, it will cancel. Still what we got? Cot A plus cosecant A. So what is the requirement to prove? Just observe the RHS. So cosecant A plus cot A. So that only we got it, cosecant A plus cot A in RHS. Therefore, which is equal to RHS. So it was satisfied and we proved.